Question 45. A teaching job offer in a school pays 37,333 Ghana cedis for the first year with an annual increase of 8% per annum. In the beginning of the second year, you have the option to either accept the 8% annual increment every year or delay the increment for 1 year and receive 10% annual increment beginning from the third year. If you choose the 10% annual increment, then how long should you work in the school before your annual pay becomes better than the teachers who chose the 8% increment per year? So the teaching offer has two options of payment. So option 1 and option 2. So for the beginning of the first year, this is the annual salary you are going to receive. You are going to receive 37,333 Ghana cedis. So for the first year, someone in the first option. So for the first year, this person will receive this salary, 37,333. Someone who also choose option 2 will also receive the same salary for the first year, which is 37,333. Now, here comes the actual work. In the beginning of the second year, you have two options. Is either you accept the 8% annual increment each year, that is, year in, year out, you receive an 8% increment. That is the first option. Now, with the second option, this is what you do. You will delay increment for the second year, meaning that for the second year, there wouldn't be any increment. But for the beginning of the third year and thereafter, your increment will be 10%. Your increment will be 10%. That is the trick. So now we want to find out the number of years that it will take for someone who chose option 2 to receive a higher salary than someone who chose option 1. So let's begin with the calculation. Now, those who chose option 1, we know that for every year there will be an 8% increment. So how do we increase 37,333 Ghana cedis by 8%? We know that in percentages, the original quantity is taken as 100%. So the original or the initial salary here, which is 37,333, goes with 100%. Remember, increase goes with addition. So in terms of percentage, this is the salary those who chose option 1 are receiving, that is 100%. Now we want to increase 100% by 8. We know that increase goes with addition. So increasing 100% by 8, we have 108%. So if 100% is giving us 37,333 Ghana cedis, then 108% will also give us an amount in Ghana cedis. So how do we work this out? So we have 108 on 100 multiplied by 37,333. So that is how we calculate for the increase. 8% increase, 108 out of 100 multiplied by 37,333. So once you compute this, this is the amount we are going to get. We have, let me use this, 4 0.64. So that is the amount that will be received after the 8% increment in the second year. Now also with the option 2 for the second year, remember there is no increment because this person will delay increment for the second year. So meaning that for the second year, this person will still receive the same annual salary. So the second year we have 37,333. Now let's move on to the third year. So the third year, remember with option 1, there is always an 8% increment. So this time we are going to increase this amount here by 8%. So we have 108 on 100 multiplied by the salary for the second year. So once you compute this, you have 43 545.21. That is two decimal places. Now for option 2, what happens for the third year? Remember for the third year there will be a 10% increment. So increasing 100% by 10%, we have 110. Increase goes with addition. So 110 on 100 multiplied by 37,333. So we have 41,066.30. That is to two decimal places. So now let's compare. In the first year, their annual salaries are the same. That is, we are comparing option 1 and option 2. Sorry. In the second year, for option 1, the salary after the 8% increment is 40,319 Ghana cedis, 64 pesos. For second year, because the increment was delayed, we are receiving the same amount as the first year. Now for the third year, option 1 is receiving 43,545 Ghana cedis, 21 pesos. Third year for option 2, 41,066 Ghana cedis, 30 pesos. So you can see that those in option 1 still have a higher annual salary than those in option 2. So let's continue. The fourth year. Let's continue for the fourth year. For option 1, fourth year, still 8% increment. Fourth year. So 8% increment, 108 on 100 multiplied by the annual salary for the third year, which is 43,545 Ghana cedis and then 21 pesos. So computing this, we have 47,028.83, two decimal places. Let's also verify that of Option 2, the fourth year. Option 2, the fourth year. Uh, this time 10% increment. So 110 on 100 multiplied by 41066.30. So let's see the result. We have 45,172.93 Ghana cedis. That is for, oh sorry, that is for 2 decimal places. Fifth year, option 1, still 8% increment. So 8% increment, we have 108 on 100 multiplied by this amount, 47028.83. Let's see. The fifth year, so that is 50791.14. Let's also calculate that of option 2, the salary for the fifth year. So for the fifth year, remember we still have 10% increment. So 110 on 100 multiplying this amount, 45172.93. So this also gives 49690.22. See that fifth year, option 1 is still receiving a higher salary than those in option 2. So let's continue. The sixth year, our space is very small. Sixth year, 8% increment, 108 on 100 multiplied by this amount, 50,791.14. So we have 54854.43. Sixth year, option 2. Sixth year, option 2, 10% increment. So 110 on 100 multiplied by 49690.22. We have 54 6 59.24. You see that option 2 is closing up. 54,000. We have 54,000, but the 100 is still more than the 100 for option 2. So let's continue the part. Maybe for the seventh year, the problem will be resolved. Let's see. Seventh year, option 1, 8% increment, 108 on 100 multiplying 54,854.43. So this gives 59,242,000 and then 78 pesos. Let's verify for option 2. 7th year, 10% increment, 110 on 100 multiplying 54,659.24. So we have 60,125.16. So what do you see? Let's see for the 7th year. So for the 7th year, this is the amount option 1 is receiving. Let's see 7th year, the amount option 2 is receiving. 7th year, option 2 is receiving 60,125, then 16 pesos. So what should be the answer? So it means that it will take 7 years for someone who chose option 2 to have a higher salary than the one who chose option 1. So we select option D. Question 46. Find the values of x that satisfy the inequality. So 3x minus 4 on 2 greater than or equal to 1/3 x minus 3. So see that we have some fractional terms. So we need to eliminate the fractional terms by multiplying each term by the LCM. So what is the LCM of 2 and 3? So that is 6. So we're going to multiply each of the terms here by 6. So the first term by 6, second term by 6, the third term by 6. So 2 goes here, 1, 2 goes here, 3. 3 goes here, 1, 3 goes here, 2. Then we have minus 6 multiplying 3. So let's see the remainder of the expression. So we have 3 multiplying 3x minus 4. Then greater than or equal to, we have 2 multiplying 1x. And 1x is the same as x. Then we have minus 6 multiplying 3. So the next thing, let's expand. The first bracket, so 3 multiplied by 3x. And then 3 multiplied by minus 4. So 3 multiplied by 3x, we have 9x. 3 multiplied by minus 4, we have minus 12. Greater than or equal to 2 times x, we have 2x. Then minus 6 times 3, we have minus 18. So at this point, we are grouping like terms. Variables on the left, numbers on the right. So 9x, we transpose 2x to the left, becomes minus 2x. Then greater than or equal to minus 18. Again, we transpose negative 12 to the right, becomes plus 12. 9x minus 2x, we have 7x greater than or equal to minus 18 plus 12. That gives minus 6. But since we are looking for x, we divide both sides by 7. So 7 will cancel out, leaving x greater than or equal to minus 6 on 7. So from the alternatives, what should be the right answer? The right answer is option A. Question 47. We are to completely simplify the expression 16 t index 4 minus w index 4. So to completely simplify here also means that we are to completely factorize. Now, when you take a closer look at this particular expression, you see that we could have easily factorized in a situation whereby we had something like a squared minus b squared. Once the index in the two terms are 2, we can easily apply difference of two squares to factorize. That is a minus b in one bracket multiplying a plus b. But here the indexes here are 4. So let's manipulate this to get an index of 2 before we can apply the difference of two squares. Now, 16 can be written as a power of 2. So that is 4 power 2. And then 16 is multiplying t index 4. Again, t index 4 can also be written as t power 2 multiplying another power 2. There is a third law of indices. So if you have something like a squared multiply another index of 3, what do? We just write the base and then we multiply the index. So we have a power 6. So the same thing. So we are doing the reverse. 2 multiplied by 2, that will give us index 4. Then this minus w index 4, this can also be written as w squared all squared, also from the third law of indices. Now, let's write 4 index 2 multiplying t squared index 2 as a single term. So in a situation whereby we have something like a squared multiplying b squared, we can combine this as ab all squared. So that is another property of indices, the power rule. So we just multiply the bases and then we square the product as it has been done here. So applying the same concept, we have 4 squared and then t squared all squared. So we can write this as a single term. So that is, so here pick 4 squared as a squared. So, and then t squared as b squared. So what did we say? We just multiply the bases. Here the base here is 4 and then the base here is t squared. So the whole of this all squared. Then minus. So we just maintain our w index 2 all index 2. Now since we have index 2 and then these two terms are subtracted, we can easily apply difference of two squares. So we just pick what is inside the brackets. So 4t squared minus what is inside the second bracket, which is w squared. Then we multiply this by the sum of the two terms. So this one, the same thing, just that the sign will change. So we have 4t squared plus w squared. But listen to the instruction given. Yes, we could see that option B, yes, is similar to what we have done, but the instruction was that completely simplify. So you ask yourself, within these two terms, can we still, I'm looking at the terms in the bracket, is there any particular term we can still simplify? Yes, you can still simplify the terms in brackets by applying difference of two squares. So the same procedure again. We know that 4 can be written as 2 index 2 and then multiplying t squared, then minus w all squared multiplying 4t squared plus w squared. Now let's write the terms in bracket. I'm looking at the first term as a single term, 2 squared multiplying t squared. So that gives 2t all squared. 2t all squared. So minus w squared. And the whole of this expression is multiplying second expression in brackets. So that is 4t squared plus w squared. Now with the term in bracket, there's nothing we can do again. We cannot apply difference of two squares. So we are only working on the first bracket. So now, how do we factorize the term in bracket? Once we have index 2, and then they are subtracting, we can still apply difference of two squares. We can still apply difference of two squares. So when we apply difference of two squares to the first term, we have 2t minus w in one bracket multiplying 2t plus w also in another bracket, then the whole of this also multiplying this bracket. So we have 4t squared plus w squared. So when we put everything together, when we factorize this completely, we have 2t minus w in one bracket multiplying 2t plus w in the second bracket multiplying the third bracket. We have 4t squared plus w squared. So this is the completely simplified form for the given expression. So what should be the right answer? So we select option D. Question 48. Given that g of x is 2x plus 8 and then g of h of x as 6x plus 15, we are to find h of x. Since we don't know the expression for h of x, let's represent h of x with a variable, let's say a. Now, what is the meaning of g of h of x? So g of h of x means that anywhere we see the function g of x, we have to substitute h of x in it. In other words, anywhere we see x in the function 2x plus 8, we just substitute a in place of x. So let's find g of x, we are finding, we are finding g of h of x. That is in terms of a. That is in terms of a. So in terms of a, it means that anywhere we see g of x, we substitute a there. So that gives 2 multiplying a plus 8. And this is simplified as 2a plus 8. So we have g of h of x, and then we have g of h of x. So these two expressions must be equal. So we just equate the two. So we have 2a plus 8. That is a new g of h of x must be equal to the old g of h of x, which is 6x plus 15. Remember, we have to find h of x. In other words, we have to find a. So let's make a the subject. So we have 2a being equal to 6x plus 15. Then we transpose positive 8 to the right, becomes minus 8. So this is simplified as 2a being equal to 6x, and then 15 minus 8, we have positive 7. Remember, we are looking for a, so we divide each term by 2. Doing so, 2 will cancel out, leaving a on the left. Then 2 goes here, 1, 2 goes here, 3. So we have 3x plus 7 on 2. But we were not asked to find a, we were asked to find h of x. So you see that h of x is equal to 3x plus 7 on 2. So we select option B. Question 49. We are to rearrange the following rational numbers in ascending order of magnitude. The first one we have 0.7, we have 1 on 2, we have 0.25, and we have 2 on 5. So to do this, we have different ways. We can either use decimal approach or the percentage approach. So let's go by the percentage approach. With the percentage approach, we are going to change each of the fractions to percentages. So to convert 0.7 to percentages, we just multiply by 100. Let's see the results. 0.7 multiplied by 100, 70%. Next, 1 on 2, we are converting to percentages, so we just multiply by 100. So 102 multiplied by 100, that is 50%. Multiplied by 100, 50%. We have 50%. Third one, 0.25. So we just multiply by 100. 0.25, sorry, 0.25 multiplied by 100, 25%. And then lastly, 2 on 5, then you multiply by 100, 2 on 5 multiply by 100, 40%. So now, remember, we are being asked to arrange in ascending order. So ascending order, that is from smallest to biggest, ascending. So for the percentages, which of them has the least value? That is 25%. So we have 25%, followed by 40%, followed by 50%, and then lastly 70%. And we know that in the question we are not given percentages, we are given in terms of fractions. So we are going to replace the percentages with their original fractions. So 25%, 25%, that is 0.25. So 0.25, 40%, we have 2 on 5, 50%, we have 1 on 2, and then 70%, we have 0.7. So that is the order. 0.25 first, followed by 2 on 5, followed by 1 on 2, then lastly 0.7. So we select option C. Question 50. A Veronica bucket is drained by 3 pipes. The first pipe can drain the full bucket in 15 minutes. The second pipe can drain the full bucket in 20 minutes. And the third pipe can drain the full bucket in 30 minutes. If all the 3 pipes are opened, then how long will it take for the bucket to be emptied if it's half filled? We have to approximate our answer to the nearest minute. So there's a question under rate. So what do you mean by rate of 3 pipes? So the rate of 3 pipes is telling us the amount of work each of the pipe can do. So first of all, let's represent the rate of the 3 pipes. So the rate of the first pipe, I'm representing that as R1. So the first pipe can empty a full bucket, that is one bucket full of water in 15 minutes. Now the rate of the second pipe, one bucket can drain one full bucket in 20 minutes. And then the rate of the third pipe, it can drain one bucket in 30 minutes. Next, let's find their total rate. So we are looking at total rate. So I'm representing total rate as RT. So how do we calculate the total rate? How do we calculate the total rate? So the total rate will be the sum of the individual rates of the pipes. So the rate of the 3 pipes will be R1 plus R2 plus R3. So the rate of the first pipe 1 on 15 plus the rate of the second pipe 1 on 20 plus the rate of the third pipe 1 on 30. So let's calculate the total rate. So we have 1 on 15 plus 1 on 20 plus 1 on 30. So their total rate here is 3 on 20. Total rate is 3 on 20, meaning that when we open the three pipes at the same time, there is the amount of work they can do, 3 out of 20. When we try to interpret this, 3, that is the numerator here, is for number of buckets. And the denominator here is telling us the time. So now, our main goal here is that if all the three pipes are opened, then how long will it take for the bucket to be emptied if it is half filled? So this time we are looking at the three pipes working together to empty a half filled bucket, not a full bucket of water, but then a half filled uh, bucket of water. So we can represent the time as t. Let's represent the time as t. Once we represent the time as t, we know that the total rate of the three pipes is equal to the number of buckets they can empty in a given time. So time here is t. So let's do substitution. The three pipes working together. So that is the total rate. 3 on 10. Sorry, 3 on 20. And then they are all working together to empty a half full bucket. So half full, 0.5. That is half. So we are looking for the time t. Since we are looking for time, we need to cross multiply. So 3 times t, we have 3t. And then 20 times 0.5. So that is half of 20. 20 multiplied by 0.5, 10. So 3t is equal to 10. And since we are looking for t, we can divide both sides by 3, both sides by 3. So 3 will cancel out, leaving t as 10 on 3. Remember, this is time in minutes. But again, we're supposed to correct our time to the nearest whole number. So let's see. 10 on 3. So 10 on 3. Let's check the decimal fraction. We have 3.3333 recurring decimal. So to the nearest whole number, we have 3 minutes. So we select option B.